Okay, so let us continue with our lesson based on the last video that I have uploaded. So the topic will be this one: network troubleshooting using ping, send, ipconfig, and lookup commands. Okay, so we'll be looking this up in YouTube. Okay, so let me copy first the title. So this one. Okay, copy this. Okay, let's see. Let's go to YouTube. This is your attendance so far. Okay, so YouTube. And let's paste this. Let's search for this. For a while here. So let's watch this first, and then after that let's discuss. So this is the video. Okay, so let's play this one.
This is Blankos, the free-to-play multiplayer game where you...
Hello and welcome to Saki Tech. So this video is about a series of network troubleshooting tools that you can use in command prompt to troubleshoot your network and get some information. So in this video we're going to go over 4 commands: the ipconfig command, the lookup command, the ping command, and the trace RT, the trace route command. So let's start with ipconfig for now. Okay, so the first command that I want to go over is the ipconfig command. The ipconfig command is a very common and very useful tool. It displays the current information about your network. So it will give you basic information such as your IP address for the computer that you're stationed on. It will give you the IP address of your router. It will tell you where your DNS servers is, where your DHCP servers are. So let's type in the basic ipconfig command to start. And usually your local area connection is called the Ethernet adapter local area connection. So this is the connection where you plug in your network cable. The RJ45 network cable connects to the jack behind your computer, and this is the information pertaining to that connection. Anyway, you can get your IP address on this screen, which is 192.168.1.10. It's also called the IP address. You can get your subnet mask right here, and you can get your default gateway address here. The default gateway is your router. So now I know the IP address for my router by looking at this screen. As you can see, you don't get much information about your local area connection here. So what I'll do is I'll clear the screen, type in CLS to clear the screen, and type in ipconfig/all to get more in-depth information about your local area connection. Just enter, and let's go back up to the Ethernet adapter local area connection. This time, as you can see, there's much more information present. The IP address is still here, the subnet mask is still here, the router address is still here, but this time you can also see where is your DHCP server. In my case, as you can tell, the IP address is the same as the router address. That means that my DHCP server is currently residing on the router. And then your DNS server, my DNS server is also 192.168.1.1. It's the same as my router address. That means my DNS server is also on my router. So you can see how this tool is helpful in troubleshooting and information gathering. Information gathering is a part of troubleshooting. So, when it comes to networks, DNS, DHCP, the default gateway, subnet mask, these are all important keywords. And we can get the information about these guys right here. So if you're trying to troubleshoot the DNS server, you can beforehand type in the IP command and find where the DNS server is. So in my case, it's in the router. So I would go to the router settings to tweak the DNS server. Okay, so let's move on to the next command. This is all I want you to know about the IP command. Clear the screen and let's get on. Okay, so one of the commands you'll be using a lot for network troubleshooting is the ping command. Ping command allows you to send a signal to another device, and if that device is active, it will send a response back to the sender. Now, for those of you who are interested in the details of how this works, the ping command is a subset of the ICMP, Internet Control Message Protocol, and it uses what is called an echo request. So when you ping a device, you send out an echo request, and if the device you ping is active or online, you get an echo response. So already you can tell why this is a good command to troubleshoot. So for example, if your router is down and you try to ping it and you get no response, then you know that the router is what is giving you problems. So let's run this command a couple times and see what kind of results we get. So let us ping my router. Ping 192.168.1.1. Press enter, and we will analyze the printout here that we got. So what happens is we send out 4 packets to the destination, and the destination responds back with the same 4 packets. So as you can see here, 1, 2, 3, 4. So this is a reply from 192.168.1 and 1. That is my router. We sent out 32 bytes of data, and we got back 32 bytes of data. And we got it back in less than 1 millisecond. Down here you get a summary. So it says packets sent 4, packets received 4, packets lost 0. So that means it's a stable connection. And then there's some statistics here, there's another port. So this is how the ping command works. It sends out an echo request using data packets of minuscule size. And then you get a response, and you know that the other device is actually alive. So let us ping Google, www.google.com, and see what happens. So we got a similar printout, which brings this to the top. And then as you can see, this is the IP address of Google, and that is where we got the response from. As usual, we sent out 32 bytes of data. But as you can see, because Google is far, far, far away and not in my basement, it took 29 milliseconds to send, to get a response from Google. And if you look down here again, statistics are packets were sent 4, received 4, lost 0. So the connection was stable. Finally, let's ping a device that doesn't exist. This is going to yield the same kind of results if a device wasn't actually working. So if your router was down and you ping your router, but you were not going to get a response from it. So let's see, ping 192.168.2.200. Press enter. So we're pinging it right now, and the request was timed out. because that device does not exist. As you can see, the ping command is retrying. It's going to retry 4 times. The first packet didn't go through. Second packet didn't go through. The third packet and the fourth packet did not go through. And as you can see on the summary, packet sent 4, received 0, and lost 4. So it was 100% lost. The signal does not exist. So if you ping the device, you get no response, and you lose all the packets. That means the system you're trying to reach is not connected to the network. It's having network problems. And this brings us to the end of the ping command. Let's clear the screen and move on to the next command. So the next command is the trace RT command. So what the trace RT command does is it lets you see step by step a route packet takes to the destination that you specify. So if you send a packet to google.com, before the packet actually reaches google.com, it goes through a couple of routers to reach the destination. So you go to your router, then it will go to Verizon or Comcast router, and from there it's going to go to all kinds of different routers before it reaches Google servers. So you can also use the term hops instead of routers. So if it takes 10 routers to get to google.com, you can instead say it took 10 hops. So how do you use this command for troubleshooting? Let's actually run the command and see what kind of results we get. So I'm going to run the trace RT command, and I'm going to trace google.com. Okay. So as you can see, we're getting a list of each of the routers that we're hitting as we are closing in on google.com. And up here we tell you that you trace it and give you the IP address for Google. Okay, so the trace is complete. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We went through 11 hops, 11 routers before we actually reached google.com. Now if you look up top here, the first router that we actually hit was my own router. I can tell by the IP address right here, 192.168.1.1, and it's the wireless broadband router.1. The next one, because I have my service through Verizon, was Verizon's router. So it clearly goes step by step through all the hops. And then after 11 hops, we were at google.com. What is the significance of this? Let's say your home network was perfectly fine, but there was a problem with the Verizon routers. You can run the trace RT command, and if there's any problems here, it will actually tell you what the problem is. It could say things like request timed out, destination unreachable, or it will also say that instead of 16 milliseconds, it could be saying like 5,000 milliseconds, just to give an example. And I don't think you'll ever see that. But so if the request times out, that means the problem lies with one of the routers that has to do with Verizon. And then you can call Verizon and you can tell them, hey, you guys are having a problem because I know that my router works as I read the trace RT command. So this is the idea behind the trace RT command as far as troubleshooting goes. Okay, so that brings us to the end of this command. Let's clear the screen and move on to the final command. Okay, so the final command I want to talk about is the NS Lookup command. This command will fetch the DNS record for a given domain name or an IP address. Remember, the IP addresses and domain names are stored in DNS servers. So the NS Lookup command lets you query the DNS records to gather information. So let's say I wanted to know the IP address of google.com. I could simply type in NS Lookup and type in google.com. Let's let's analyze this code. So the first two lines here show which DNS server was used to get these results. My DNS server happens to reside in my router.
Nagtitake lang po ng bagong pictures na video ko para talaga.
So that is also my DNS server. And the answer that we got was this. All these IP addresses here are Google's IP addresses. Now Google is a huge website. Obviously it's not going to have one single IP address. Obviously the IP addresses will change from time to time. But if you type in any of these IP addresses in your browser, it will take you to Google.com. So this is the basic idea behind the NS lookup command. Okay, so this brings us to the end of this video. And if you guys like the video, just click the like button. And if you like my videos, subscribe to my channel because I will upload more and more.
Okay. So let me explain itong video regarding sa ping sa trace RT or trace route, ipconfig, and then the NS lookup commands, no, sa ating command prompt, okay, for troubleshooting on network. Okay, first, okay, move forward ko lang. Okay, we have the meaning of ipconfig command, which displays all current TCP IP network configuration values. It gives basic information. Get your IP address, your router's IP address, DNS server IP address, HTTP server IP address. So let's go first and let's have a demonstration of the ipconfig command. So I will click on search and then I will type CMD in order to open up my command prompt. Okay, and then here, then I will type ipconfig for starters. Okay, so here's our command, ipconfig, and I hit enter on the keyboard. It will show me different IP addresses that is connected to my computer. No? First, I have my IP address, IPv4 address, which is 192.168.0.103, and then I have my subnet mask, which is 255.255.255.0, and then my gateway, which is 192.168.0.1. And I can further look some other details about my network if I type an additional command on the ipconfig, that is ipconfig/all. Okay, this is a more detailed list of addresses from where it shows me my physical address or MAC address, okay, which is on a hexadecimal number, which has my MAC address is C0188590E 0DDE, and DHCP enabled, and then we have DHCP server address, IP address, which is 192.168.0.1, DHCP v6, and a lot of descriptions here. Okay, both Ethernet connection and wireless LAN adapter connection. That's ipconfig. Okay, next network troubleshooting command is I think the ping command. Okay, ping command. The ping command allows us to get the status of a certain network or of a computer in a network, whether it is active or inactive, whether it's connected or not. So we have this description of ping or ping command. Ping command allows us to send a signal to another device on the network to see whether it is active or not. So let's try some demonstration here. So I will go back with my CMD. I have some data here or information. So to clear the screen of my CMD screen, I will type clear on the command prompt. Okay, clear, and then rather CLS. Okay, to CLS stands for escape. Okay, let's try with the ping command, ping, and then the IP address. Let us have let's contact, or let us make some echo on youtube.com, whether YouTube is active or not. So ping youtube.com, and when there is a reply like this one, reply from 117.25.14, meaning youtube.com is active. Okay. If there's no response, then the network, the device on the network is not active, whether the network is disconnected, or the computer or the device has some issue or problem. Okay, so that's the ping command. So we have the ipconfig, then we have the ping command, and then next we have the trace RT or trace route. Okay, the trace route command is used for, of course, tracing our router. Okay, and another one is lookup command. Okay, so those are the four basic network commands that we can use. So trace route or trace RT is a step-by-step route. Okay, route a packet that takes to the destination which we specify. Okay, so in other words, traset or trace route is used to trace the router. Next, let's go to lookup. Lookup is used. This command will fetch the DNS record for given domain like YouTube or Facebook, or IP address. Okay, remember that the IP address and domain names are stored in the DNS servers. So the lookup command lets you query the DNS record to gather information. So those are the basic network commands that we have, or we can use, especially the the ipconfig command and the ping command. Okay, additional is this lookup and a trace route command, and also kindly include the CLS command for clearing our command prompt screen. Okay, so that's the summary of this video. So let us move to the next one.
Lookup command.
Okay.
This command will fetch the
Okay, so
DNS
let me check. So we have next how to check system configuration. Okay, let me copy this first. Okay, and then search it to again YouTube. Okay. Okay, then paste this one. How to check system configuration. Let me see the timeline. That's 244. 244. 244. Maybe this one. This one. How to check computer Windows. No. So maybe we'll how to check system configuration. Okay, let's try to look for it. That's again 244. This 44, but it's in Bangladesh. It's hard to look for that video. 233 Tamil. If I cannot find this one, let's use the top videos instead. Okay, let's do that. Okay, let's use the top videos rather. Okay, this one. How to check computer configuration on all Windows, or how to check system configuration. Okay, so 251. Let's play this first and then I will explain. Okay, so that's the video. So let us have a demonstration regarding on checking the system configuration on any Windows computer setup. So first we go to search bar, okay, and then we type the run command, RUN, then we press enter, okay, and then after that in the open text box we're going to type dx diag. Dx stands for direct, diag stands for dialog. Okay, so let me type that. So dx diag. Okay, and then after that we press enter or click OK. Okay, and then after that the DirectX dialog box will open, from where from that dialog box all the system information are shown to us. Okay, so we have 4 menus or tabs. We have System tab, Display tab, Sound tab, and Input tab. Okay. So in my example, in my laptop, okay, I have my system, current system, the day-to-day, the computer name, which is desktop-B10A CCJ. Operating system is 10 Pro 64-bit. Language is English. System manufacturer is NEC. System model is PC-BK20EANCN. BIOS is inside H2O. Processor is Intel Celeron dual core, okay, at 2 GHz each. Memory is 6 gigabytes. Page file is 560 MB. DirectX version is DirectX. So that's my system information. And then here's my display information. I have my Intel HD graphics by Intel Corporation. Full display 200 MB. Okay. Yeah. Then we have in sound. Okay, the information regarding to my sound. I have my Realtek high definition audio speaker, and then for the hardware I have HD audio. Okay, for the driver I have RT-KB HD 64.6, and that provider Realtek Semiconductor Corporation. And last but not the least, we have the input both for the mice and keyboard. Okay, so for my mouse, I have an attached mouse. I have a 2.4G mouse, which is my wireless mouse. I have my keyboard, okay, which is my USB keyboard, and of course my laptop keyboard and a CHID mini driver for hardware ratio switch keyboard. Okay, so these are all my system configuration and information. And if we want to save this and print this information all in all, we just click save all information, and we can save it into a text file. Okay, text file or XML file if we are going to publish it to the web. So at first we are saving it to a text file, and then we open it in a Word file. Okay, so that's how we can look the configuration of a computer system by going to the dxdialog command, okay, in our run command. Okay, so dxdialog again stands for DirectX dialog. Okay, that is our diagnostic tool for checking the system information and configuration. Okay, next topic, to the third one. So how to make a LAN connection in Windows 7. Okay, so that's the title. So let's look for it in YouTube. Okay, so paste this here, and then let's look for it. So how do we make a local area connection in Windows 7? Okay, so that's 429 timeline. So this one, English subtitle. Again, as usual, let's watch this, and afterwards we are going to discuss this. Okay, so let's play it. Okay, so that is how we create a LAN connection in Windows 7. So let us try that here in my Windows 10 to simulate that, if we can do that. So first, we will go to computer management. Okay, in Windows 7, that is in all programs, then control panel, and in control panel, we will select computer management. Okay, so let's see that. Okay, here. Oops, sorry for that.
Connection is the easiest network connection to set up.
Back.
In order to set up a wired connection, you
Okay, here. Okay, so first go to your control panel, and then after that, you will select system and security. Okay, and under system and security, you will click the administrative tools. Okay, and then under administrative tools, we will click computer management. Okay, so let's do that here in Windows 10. So what I'll be doing is I will go directly to computer management. I will skip the first three steps, control panel, admin tools, but rather I will go directly to computer management. So go to search bar, and then I will type computer management. Okay, computer management. So the same with Windows 10. Okay, that's computer management. Okay, so that's our dialog box for computer management. Okay, so next step, after opening up computer management, okay, here we will double click on device manager. Okay, and then we will open the network adapter. Okay, select network adapter, and then click on action menu, and then double click on add legacy hardware. So let's do that. So let us go first to device manager, now our computer management. So here, and then after this, we will look for our network adapter, this one, and then afterwards I will click on action, then add legacy hardware. Okay, action, and then add legacy hardware. Okay, then after this, we will click next. Okay, then we will install the hardware. Okay, select the second option, then we will click next, and after clicking next, okay, here next, second option, then next. Okay, after clicking next, we will select our network driver. Okay, we will look for that. So network adapters, we can click that and then click next, or we select network adapter, click next, and then we will click Microsoft, and then we will go to Microsoft Lookback adapter, then click next. Let's do that. So we have here network adapter, so I will choose that, and then click next, and then here I will choose Microsoft, and then I will look for the Lookback adapter, so this one, KM test Lookback adapter. Okay, and then I will click next, and then I will click next again, and it will install the Lookback adapter. Okay, So just play this one. Click next after seeing the loopback adapter. Then click next, installation, and then click finish. Then after clicking finish, we will go to network and sharing center, and then properties IPv4. Okay, so let's do that now. So finish, and I will close this one. I will go to my sharing and network, network and sharing. Okay, network status and network and sharing center. Okay, which is this one. Okay, and after this, okay, we will change the adapter settings. Okay, so where's that? So we will locate first the network. So view network status. Okay, and then change adapter settings, and then choose the network. Okay, so let's do that. Go CMD and here, change adapter settings, and then this one unidentified, and then properties, and then IPv4 settings. This one, properties, use the following address. Okay, next. Okay, we will type this addresses 192.167.1.1. Then automatic the subject mask, and then we have the default and gateway. Our gateway is and copy the IP address 192.167.1.1. Then click OK, and then click close. Click OK. Close. Okay. And that's it. Hopefully there is a new LAN connection. Okay. But unfortunately we don't have a wired cable here, so we cannot test it yet. Okay. So there is it, Ethernet tray. Okay, I will close this now. And for our last final lesson, we have WAN interface setup. So I think I will just play this one. Okay, how to set up our WAN interface in order to connect to the internet. Okay, and then that is 8 minutes. Okay, 8 minutes. So here, okay, here and then here.
Hi, and welcome to a Sonic Wall Firewall video tutorial. My name is Micah Vorst. In this video, I'll set up a WAN interface so our end users can get out to the internet. Setting up a WAN interface is one of the first things to do when installing a new firewall. There are 5 different options when configuring a WAN interface. The most important or common choices are static and DHCP. Static setup allows a firewall administrator to manually configure the WAN interface. This includes the assigned IP address, subnet mask, default gateway, and of course, DNS servers. The second option is DHCP. If there is an upstream device that automatically hands out IP addresses, DHCP can be used to remove the manual work. Usually, if there are web servers or other types of servers that need to be accessed from the internet, using the static option is preferred. The remaining three options to use for WAN setup are PPPoE, PPTP, and L2TP. These options allow for server information, username and password, as well as different options for static or automatic IP assignment. Configuring a WAN interface allows end users to get to network resources, and in most cases, connects them to the internet. In our example, we haven't set up the interface yet, so our end users can't get online. Let's change that. In this demo, I'll use an NSA 6650 on SonicOS 6.5 firmware to configure a WAN interface using the static IP assignment. Let's go ahead and log in now. Before proceeding, now would be a good time to export a settings file and store it in a safe location. Let's do that now by navigating to Manage, Firmware and Backups, Import Export Configuration, and Export Configuration. The default file name is fine. We'll simply select Export and save to our Downloads folder. For this to work, we'll need to know our assigned interface IP, subnet mask, default gateway, and DNS servers. I have those with me, so we should be ready to configure the interface. Let's navigate to Network, Interfaces. Click the edit icon next to the WAN interface. I'll use the X1 interface. Currently, how we have things set up is that the zone is already selected as WAN. But if you're using a different interface and it's not assigned, simply select WAN zone and then the IP assignment option. In our case, we'll select static. I have the information that I need. 10, 61, 134, 113. Subnet mask, 258. Default gateway, 10, 61, 134. For DNS server, we'll just do a default Google server for now. At this time, I'm going to turn management off, but we're going to come back to that here in just a few moments. Let's click the Advanced tab. Under the Advanced tab, we can change link speed, change a default MAC address, the MTU size, and other administrative settings. The defaults are fine here, so let's go back to the General tab and talk about the management option for a moment. Depending on your environment, you may want to manage the firewall via the WAN interface. I strongly recommend that if you enable WAN management, that you modify the default access rule and change the source to known sources that you'll be managing from. For example, your home or office. Let's click Manage HTTPS and OK. I'll create an address object for where I'll most often manage the firewall. Navigate to Manage, Objects, Address Objects. We'll create a new address object called Custom Management 1. We'll click Add, Custom Management 1. We'll give it a WAN zone. This is not my real IP address, but it is an example of where I would be coming from if I wanted to manage the firewall. We'll select Add. Now, in the future, I may want to add more IP addresses, so I'll create a custom management group and add this new address object to the group. Simply select the Address Groups tab, Add, Custom Management Group, and then add the address object that was recently created. Next, let's go to Rules, Access Rules, and select WAN to WAN. If you don't see it right away, make sure you change the from and to both be WAN. Alright, we see a few different access rules. Our first is to allow ping. The second is for HTTPS management, actually. I'm only going to change this second rule because I'm okay with people pinging the interface to make sure it's up. We'll edit this second access rule, change the source from any to the custom management group. Once we hit OK, we can verify that the change has been made by hovering our mouse over the custom group. Great, we see the address object. As we continue to add more address objects, we'll see more and more hosts being added to this list. This will effectively lock down remote management to only my specific IP addresses. After we're done configuring the interface, we'll use the built-in system diagnostic tool to confirm that the firewall is online. Navigate to Investigate, and then System Diagnostics. We're going to select all the test server options. Under System Diagnostics, we'll change the diagnostic tool to Check Network Settings. As you can see here, we have a few different servers that we can test from. We'll select all of the servers and click Test All Selected. This simply sends out an acknowledgement and waits for a response. So for some it's pinging, for some it's also HTTPS connections. Perfect. So we can see that the firewall is able to access servers that are online. From our end user, we can test by opening up a command prompt and using ping. The test that once failed now works. We know everything is working as expected. I recommend saving another settings file so that you have a last known good configuration. I hope this tutorial was helpful. To learn more about configuring SonicWall products, visit www.sonicwall.com/support.
Okay, so that's the setup for WAN interface for SonicWall, an ISP in the States. Here in the Philippines, we have PLDT, Globe, Converge, okay, Red Fiber. Okay, so let's visit their WAN interface. So let us have two. First, I have here PLDT, WAN interface, okay, or user interface. So tsura niya is ganito. Okay, so here I cannot make a demo here because I don't own the ISP here. Buti ko na sa bahay. So ito yung tsura ng WAN interface ng PLDT. Okay, so we can change the SSID of our Wi-Fi. We can change that. Even our username and password, we can also change that. Okay, so this is the user interface of PLDT. This one, there is a administrator and password, so we need to input that, and the user interface. Okay, we have the management tab or menu and some more options to do sa SonicWall, etc. Okay, this one, status, network, security, application, then management. Okay, let us visit naman yung sa Globe. Okay, Globe WAN interface. Kaya itong dalawa kasi both nakita ko na. Yes po. PLDT, meron ako sa uno. Then, Globe SAT, ayun naman. Okay, sa Globe naman, ganito yung tsura ng kanilang user interface or WAN interface. Okay. Okay. So for Globe, so here, so may LED, may power DSL, internet, LAN, LAN 2, LAN 3, etc. This this one also may network security. So, pwede din balitan ng SSID and the user name and especially yung password. Pati makita natin kung sino yung mga connected sa ating ISP. Pwede natin silang kick or i-block do sa ating WAN interface. So yan yung sa WAN interface and connecting or configuring our internet. Okay, so that's it for now, class. Okay, this is my second recording for our lesson for today. Thanks, and that's all. Bye for now.